Thank you, everyone. Yeah, it's nice to be back at conferences, and yeah, it's the first time speaking at a conference after the whole COVID shenanigans, but it feels good to be back, right? Cool. Thank you for coming for the talk. Today I'll cover how we implemented and developed a tool for us to help us to implement parallel execution of offensive security. We'll go through today the problem with scale. Some of us may have challenges with scale when we do some types of offensive security activities, or when we do pen testing on a large attack surface area, or when you're doing bug bounty. But some of us may not be facing that challenges. And today I'll go through and illustrate, hopefully, an example and scenario that many of us may be familiar with. And then thereafter, state the problem statement, essentially what kind of problems we need to solve when we look into scale and when we look into how we can scale offensive security activities. And then all of us will go through together with this thinking process of how we build these two together and how we can then use these two, what features we need to fit into this tool to help us to scale offensive security activities. Right, so I'm Samuel. I'm a principal security researcher at watchTowr. My previous roles, I've been doing red team as well as penetration testing activities in consultancies. And I've been engineering offensive security tooling for red team as well as penetration testing activities. Essentially, I'm a nerd. So yesterday when we had a community night, some of us were, at least for me, I was soldering this badge essentially. I was soldering this badge with LEDs at one corner instead of having alcohol. But yeah, I'm a nerd essentially. And some of us at a whiskey bar after the event were arguing about what's the best way to be stealthy in a workstation. So that's what I do, and I've been enjoying building tools for red team toolings, and also have shared some of them in some other conference like InfoSec in the City, or SynCon what it was in 2019 before COVID, and a few others before COVID, and it's great to be back again. So what challenge are we trying to solve technically? So what we do at watchTowr is we have to be able to react to real-time attack surface discovery. We need to also have rapid reaction to emerging threats, and have holistic scope on different types of asset types. What this means, firstly, in terms of real-time attack surface discovery, is we need to continuously look at multiple information sources at a large number of assets. And when we look at so many assets, we need to be able to make sure that all our executions are fast and all our execution can complete. One single machine simply isn't able to cover these types of assets. Another requirement for us is we need to be able to have rapid reaction to emerging threats. For example, when Log4j drops, when there's a Spring4 shell, when there is a blue kit that drops today, how confident are you to be able to use a single machine to cover your entire attack surface and to make sure that they are secure? It is unlikely that you are able to do that in a reasonable amount of time compared to the attackers that is also scanning your infrastructure whenever a vulnerability drops. And lastly, we also need to be able to cover different asset types. So this means that we need to quickly leverage on different types of open source tools whenever we have new asset types or whenever we have a new attack technique that comes along. We need to be able to quickly incorporate these tools onto our platform. And that means our tool to help us to scale our execution, we need to have scale. And secondly, it also needs to have flexibility. Perhaps those situation is a bit abstract. So I'll go through a scenario that many of us may be familiar with. So let's do a bug bounty together. We are doing a bug bounty on company A for a company that may or may not start with the letter A, or may not exist. But this company is ACME Travels, and it's a prominent company in bug bounty payout. And it operates a global technology operations for traveling purpose. And in terms of their bug bounty scope, there is 16 root domains listed on the bug bounty scope. Sounds simple, right? 16 root domains, let's find some bugs, and let's make some money. So first step that we need to do is to discover a attack surface that this company would have. And sorry for the guys for Yes We Hack. I didn't know you guys sponsored today's event. I would have changed, instead of HackerOne, I would have used one of your clients perhaps for this scenario. But this would be an example of how ACME page in the HackerOne page would look like. They stated 32 assets in scope, right? Well, such a small attack surface, you can easily cover that in using a single machine and just look through 32 assets. Well, that could be the expectation that some of us might have. When we look deeper, the organization, And for this specific company, you actually have more than 200 root domains. We have more than 5,000 subdomains, more than 30 ASNs, more than 5,000 IP address, unknown number of ports open, as well as unknown number of cloud buckets, mobile application, repositories, so on and so forth. And the reality is that organizations have many types of assets they have deployed: production, staging, pre-production, development, and many other kind of environments that you simply need to dig further. And once you discover them, then you need to conduct your offensive security activities on all these types of assets. The truth is, more than likely, you will be the production application or the .com domain is likely to be relatively secure for bug bounty, from a bug bounty point of view. But there will be many kind of bugs that you'll be able to discover on perhaps their application that consumers don't use. Some applications could be staging that's exposed on the internet, and these same servers could be domain joined, which then you can use to enter or gain a foothold onto the organization's attack surface. So fine, some of you might think, okay, 20,000, let's run port scans across 20,000 assets. I mean, 20,000 doesn't sound like a huge number. Well, and some of you might ask me, have you heard of min rate? You can just run Nmap with a min rate more than 9,000. So let's do it. Well, I did a port scan with service discovery on IP address, and I just ran min rate 9001. This is just an example with service discovery. And some of you who have been doing offensive security, some of you who have been doing penetration testing, some of you who have been looking into bug bounty for external attack surface, this could be very familiar to you. You see 65,000 ports open, and then your Nmap will then, or whichever tools you use, will then have to do service discovery 65,000 times for each IP address, because this IP address might be behind IPS or IDS, and it's simply returning port open for every port that is probed. And in this example, it took 12 minutes and 52 seconds to cover one single host. We multiply that by 20 IP addresses, we will get approximately 138 days. This is simply not sustainable if you are running a bug bounty, you're trying to find bugs for an organization, or if you are doing a penetration testing engagement against a large attack surface area. Another approach that you might have for this bug bounty will be a rapid reaction to new threats. Perhaps you have found a debug path on a specific host. For example, admin.acme.com/debugpath.acme. The next reaction for you in a bug bounty scenario will be that this mistake can't be made just once. You will want to be able to check every single other host if they are making the same mistake of exposing this debug path into other attack surfaces as well. So one simple approach is just spray this path across 20,000 assets. And if you actually do the math, and maybe each path will take 1 second to respond, and you have multiple concurrent threads in a single machine, 20,000 assets, frankly, wouldn't take a huge amount of time. It's a few hours, but in the whole scheme of things, depending on your bug, a few hours might be acceptable. But what you will then see is because of WAF, because of IPS, IDS, because of IP blacklisting, your single machine might even be blocked by the time you reach your first 1,000 hosts. And your next activities, your next 2-3 hours that you spent scanning through in a 19,000 hosts will all be blocked, and it will be a huge waste of your time. Or you might even give it up, and actually there's tons of vulnerable hosts in the next 19,000 assets that would have been blocked because of WAF, IPS, IDS, or IP blacklisting. And lastly, after you have found some bug and filed them, the next thing you'll do will probably not be just to throw this away and move on to the next host, because you have spent so much time discovering attack surface, you have spent so much time looking at assets, and looking at this organization. There's 1,300 reports resolved, 1,300 bugs solved. So what is the likelihood that they'll stop making bugs the moment you send the report? The answer is 0. There's likely more bugs to be found. There's likely some infra guy, some DevOps guy, some application guy. They'll be making the same mistakes or new mistakes the next day, the next week, or the next month. You want to be able to continuously do bug hunting on these attack surfaces. So what about cron job? One easy way is create a cron job, put some command, say bounty please for good luck, and then run tons of cron job on a single host. and then a cron job runs, I don't know, every minute, every hour, every month, every week. It's trivial, right? But the truth is, if you run so many cron jobs on multiple organizations with different types of goals, you'll likely hit this, or maybe this. You'll hit out of memory, your host is likely to crash, you'll likely not get results on that single host. So hopefully, with this scenario, I've demonstrated that you will need to scale. In this scenario for bug bounty, you will need to be able to scale because you need to be able to handle a large amount of workload. You need to scale because you are trying to build a tool to be able to have multiple outbound IP addresses. What I've always had a great discussion with our internal DevOps engineer is that he loves Kubernetes. And to me, I feel that Kubernetes is a good tool to kind of manage inbound traffic and to help organizations scale inbound traffic. But for me, I'm building something opposite. I'm trying to build something that scales outbound externally. And I always joke with him that I'm essentially building an internal botnet. Because the truth is, we need multiple outbound egress IP address so that we're able to cover the situations of IP blacklisting as well. And lastly, we also want to be able to have a tool that we can be able to schedule jobs and to be able to ensure that we have continuous bug bounty hunting or continuous assurance or any other kind of continuous activities you are doing at scale. So let's build a tool together. Before we go deeper into what the requirements for the tool is, I kind of naively built a model of what a standard offensive security OSS tool might look like. This could be any other CLI tools, really. But what a standard tool will look like, it's for OSS tool, or open source software, or any CLI or command line interface tool, you essentially have a standard in and input files and additional files that the file might use, like word lists, like configuration files, or any other types of files. And the tool will then give an output, maybe standard error, standard out, or a file output. And when we extrapolate this model of our offensive, of what the OSS tool will look like, then essentially you need to scale this tool or scale the execution of this tool across different hosts, across many concurrent tasks running at the same time, across many workers. So what do we need? Going from the previous example that I have spoke about, we actually need something that helps us to be able to split our tasks up into different smaller tasks. I think this is generally quite straightforward, and I probably don't need to elaborate further. Next, we need to be able to handle flexible infrastructure and also handle different types of tooling available on open source software or any other tools that you might want to incorporate. This means that perhaps you might want to have different source IP address. Perhaps hosts from AWS is getting banned. You might need to have different hosts to do your bug bounty hunting on GCP, on DigitalOcean, on other types of cloud provider or VPS. And you also need to be able to incorporate tooling relatively easily whenever you have a new idea or whenever you develop a new tool to use that tool to conduct offensive security activities. You want to be able to incorporate that very easily. And lastly, you will need some form of task queuing because, as we have demonstrated earlier, having a cron job that runs 100 tasks every second, every minute is not sustainable. You need something to be able to help tasks queue and help tasks run so that you can manage the resources across n number of hosts that you may not be able to manage. And also they might, so that they don't crash arbitrarily and then you have to handle the monitoring of these tasks. So how do we split the task? I think this part is probably the most straightforward part. If you have a task with task 1 to task 6, the easiest way and the most intuitive way is to round robin these tasks. So one easy way is if you have 3 hosts, you then send the first task to the first host, second task to the second host, third task to the third host, and then the fourth task will go back to the first host. So generally this is straightforward. And it's probably the easiest way to just implement how we split the task anyway. So the second part is how do we then communicate? Well, in terms of execution of this task, there are a few things we need to communicate, and we need to kind of communicate with each workers on. The first part we need to send is the round-robin input files. So after we split the task up into multiple smaller tasks, we need to send these tasks to each of the workers to execute. Secondly, we also need to send any auxiliary files to each of the workers so that the workers will be able to work on perhaps word lists or configuration files for the execution of this offensive security task. And then also need to be able to execute commands, so just send a command over and make sure that these commands are executed. In terms of output, we have the output file, standard error, as well as standard out. So as we kind of brainstorm together, there's a few ways you can communicate. First way, it's just build a bunch of workers that just ingest RESTful API. I think this is relatively straightforward. We can just build API relatively easily. The challenge of having RESTful API, firstly, is that the schema, we need to kind of determine a schema. And when there's upgrade, you of course need to upgrade both the workstation as well as the controller. And second complication brought about by a RESTful API is you will need a controller, because it needs to be able to handle the sending of the RESTful API, or perhaps you might want to send an API directly through each of the servers. Then there will be higher complication in terms of your overheads to be able to send the task across to multiple workers. And lastly, RESTful API isn't really the best way to send binary files. Of course, they could be compressed in traffic. When you send a binary file, maybe base64 encoded or hex encoded in the traffic, but by and large, it is not the easiest way as well as the most suitable way to send binary files, to send input files, to send different types of files in the traffic. Yep. The next way we can communicate is we can use message queue. Having message queue would then incorporate additional hosts, maybe RabbitMQ, maybe Kafka, that we can incorporate as a message sender. So then each of the workers will communicate with the message sender, and then the workers will then be able to ingest this task and take this task easily, and then work on this task with the message queue. It has quite a few advantages, actually. Firstly, it is relatively low latency compared to the other options. Second, it is also able to help us to be able to do queuing of tasks, as later on I will kind of elaborate more on as well. But for the message queue, the disadvantage is you just throw essentially a message on the message queue. So similar to the RESTful API, it is not the most effective way of sending binary files or any types of file of arbitrary format on the message queue unless you do some kind of encoding. Secondly, you need to be able to send a task out in this standard formatting. Then you need to be able to handle the sending of these tasks. And lastly, in the message queue, it cannot, or rather it is much harder to be able to handle the dynamic situation where you add any number of workers arbitrarily. Today, you have to add new workers. Both your controller as well as your workers, as well as the message queue, have to be able to handle adding of workers or removal of workers as we do this task together. And then, lastly, SSH and SFTP. I think one part I kind of missed out earlier in terms of elaborating is that there are some tools available. Before we go into design this, we did look into different tools available that can do something similar in terms of sending out dynamic tasks or sending out bigger tasks to be able to split across multiple workers. Some of these tools include Axiom, include Flix Security, includes Scantron. And for some of these tools, I'll just give a quick introduction of what each tool does. For Axiom, essentially, the developer generally focuses on being able to dynamically set up an infrastructure and then sends out the task into smaller chunks for each of the workers to complete. But they don't have very reliable dynamic task scheduling to be able to handle the task scheduling and to prevent, say, the workers from crashing. So Flix was similar to Axiom as well. And these two tools have a similarity, which is they are both SSH and SFTP based. So what they do is they simply take a task, they split the task into smaller tasks through SFTP, and just send a command on SFTP for them to complete. So I actually took inspiration from them for SFTP as well as SSH as well, because it is generally a protocol that's well established, relatively secure if you set up your authentication properly. Without password, with passwordless login, you only authenticate through a key and set up an exchange securely. If you set up securely, generally it's a secure communication, and it's also flexible enough for you to be able to deploy on any different type of cloud environment and to be able to just use SSH as a transport protocol instead of RESTful API and message queue, which is harder to implement across multiple clouds, depending on what you have exposed on the internet. So exposing a Kafka on internet is probably a little bit more sketchy than exposing SSH, in my opinion at least. Yeah. And for the communication style, then we have decided SH as well as SFTP will be an easy way for us to be able to communicate and send out these tasks and commands easily to each of the workers. And lastly, what options we can choose for queuing of the task. Sorry about that. Yeah, perhaps I'm too far. So one option we can choose for the queuing task is controller-based. So what it means by controller-based? One easy way is you have, and in fact, this is what one of the tools, one of the earlier OSS tool that I mentioned actually does for Scantron. So what controller-based means is you have a controller that takes in a huge task on itself, and when the controller takes in this task, the controller itself will manage the status of these tools, and the controller itself will split these two up into multiple smaller chunks for each of the workers to work on. The advantage of this is generally a controller is a single source of truth. So you face very little kind of data discrepancy, because as long as the data is correct on the controller side, everything else will be accurate, and you will be able to check the status of the task on the controller. The disadvantage of a controller-based system is firstly you need a controller, so you need to be able to have one additional host. But frankly, if you scale this relatively well, a controller isn't that huge of overhead. But really, another kind of downside of having a controller base is it's hard and it is not flexible for us to be able to add new tooling. And that's the real reason why we didn't choose controller-based platform or controller-based kind of task queuing. Because every time you throw a task into the controller will need to be able to handle the new types of tasks, the new types of commands. Of course, that can be made flexible, but generally, there may be some code changes depending on how the tasks are executed on a controller base, and this will result in the lack of flexibility if we were to use a controller-based task queuing. The next option we can choose, back to message queue again, is essentially message queue. But like what I mentioned earlier, message queue adds on overheads in terms of adding inflexibility of heading the task, because once the task is thrown, the tasks have to be split up before it sends on the message queue. And then message queue essentially adds advantage onto latency, but generally for other areas like flexibility, like being able to needing to have a controller and having single point of failure, generally adds more complexity for us instead of as a viable option for task queuing. And lastly, daemon-based task queuing. Essentially what this means is we have a daemon on each of the workers, which is needed anyway for most of the other options. But what the daemon then will manage the queue, what the daemon then will do is to manage the queue internally for each of the workers. So each of the workers then will have a daemon on itself to be able to manage the task that is sent to the daemon, and then the daemon will then just work on the task whenever the next task is completed, and then the daemon will work on the next task, and the daemon will then store the results that make it available for collection. And then whenever the hacker workstation is ready to collect the data, the hacker workstation can then query the workers to collect the data back to the hacker workstation without a need for a controller or the need for different kind of moving components in this entire framework. So all in all, looking at the different options for our purpose, of course, different tools have different kind of goals. Like there are different open source tools available to do similarly what we have done as well, like Scantron, like Axiom and other tooling. But what we have decided for SmallFish is in terms of task dispatching, we have decided round robin as a task dispatching because generally that's the most straightforward method for us to be able to send tasks across multiple workers. In terms of task transportation, we have decided to use SSH and SFTP to send the files, and then this will just simply send the task or the auxiliary files on SSH or on SFTP, and then sends the command on SSH. And lastly, in terms of task queuing, it is essentially daemon-based, and this will allow the task to be managed on each of the workers after sending the task to each workers. So how does it look like altogether? Well, essentially, just now we have shown some example of this chart altogether, but essentially, the hacking workstation will then be able to communicate with each of the worker directly through a daemon, and then each of these daemon will manage multiple tasks running within each worker host, and then having a concurrent number of tasks running, and then all the communications as well as all the tasks will be sent from a hacking workstation directly to each daemon, and then that hacking workstation may have a different task scheduler on top of it, whether it's cron, whether it's other kind of data processing or data scheduling platform attached to the hacking workstation or as a service. So what have you looked at it in conclusion? Well, hopefully today I have kind of demonstrated that there is a scale challenge in today's problem that we're looking at. Organizations are getting bigger, organizations are having more things on the internet, and organizations have more things to secure. Whether you're a bug bounty hunter, whether you are a penetration tester, whether perhaps you are working for security for an organization and you're looking into perhaps different types of scans to be done internally for internal assurance activities, you have a skill problem. And that's where there is a need to parallelize tasks because you have a skill problem. And to parallelize tasks, there are different options you can choose, whether open source or whether you can internally develop a tool to parallelize the tasks. But essentially, there is a need to parallelize tasks because of the challenge with the skills challenge that you may face today. And lastly, of course, there's different paths for different goals. Today, we have specifically looked into the goal of, in the example that I've given you of solving bug bounty challenge for a specific host. But depending on your situation, whether you could be working for a blue team, you could be working for different types of tools, you may or may not choose different paths. And all these paths are equally viable. We have seen Scantron, Axiom, as well as Flix taking different paths and different approaches for parallelizing tasks. And the truth is they have different goals. Like Axiom, their goals is to be able to build a dynamic framework, dynamically infrastructure framework, rather than the task side of things. And for us, that is something that is not the focus because we have to develop or we have to spin up infrastructure based on our requirements, and then that is not allowed to be dynamic. So essentially, there is different paths for different goals, and we have decided for us to take this path of building this framework to help us to be able to parallelize tasks in that manner. Right. So that's all for the presentation. I'm opening the floor for questions. So now it's time for Q&A. Thank you, guys. Sorry. Thank you. Sorry. Any question? Oh, yes, sir.
So I think when you have a lot of tasks like this, makes a lot of sense. But when you have less tasks, right, that you want to run, and you have all those workers that are running, but they're not doing any work, like how do you account for these additional overhead? Do you spin them down? What's the strategy there?
Right. Thanks for the question. So that's a good question. So for us, one of our key goals is we need to be able to continuously look into the attack surface of our different clients and different attack surfaces. So for us, any activity is ongoing at the same time. So there will always be activities ongoing because of our task scheduler. So we have a task scheduler that's separate from this infrastructure. And a task scheduler would schedule tasks continuously to make sure that the workers are occupied. But in terms of infrastructure, we can spin the workers up and down. And the purpose of this as well is to be able to allow the workers to be spun up and down relatively easily. And because there is no controller overhead in this infrastructure, there will be no need to integrate a worker to a controller whenever we add a controller or remove the controller. We can just change the config file, add additional tasks, and from the hacking workstation or from the task scheduler point of view, we will be able to dynamically spin up and down workers on the fly. Right. Thank you.
Sorry if I missed this at the beginning of your talk, but will you be planning to open source SmallFish at any point in time?
Right. So for SmallFish, we are planning. That's on the roadmap, but I think right now it's not in a state ready to be shared on open source because there are some kinks around how it's working. So we are still kind of smoothing out the kinks, but that will be for kind of a larger timeline to open source that.
Yeah, hi Samuel, thanks for the talk. I have one question regarding the scans. So nowadays, a lot of the assets on the internet, they are either behind CDN or behind, say, zero trust proxies. So how would you know that you're scanning the underlying origin server and whether these vulnerabilities that exist on the server may not be reflected when you do the scan on the proxies? Yeah.
Right, thanks for the question. So for this question, it is generally a harder question to kind of look at from each scan point of view. So actually we differentiate based on the results, and we have a number of heuristics internally to differentiate the response if you're hitting, say, for example, a Cloudflare 401 or different types of payloads that could be blocked. For us, we have also a slight advantage, which is we can ask our clients to whitelist our IP address. So from that perspective, we do have an advantage where we face less of that problem, but we still face that sometimes because sometimes some IP addresses are not whitelisted, or sometimes certain assets are found that doesn't belong to the organization. So in fact, facing that challenge was one reason for us to develop SmallFish, because when we kind of running on a few fixed number of hosts, we see that these IP addresses were very easily blacklisted, especially when they come from AWS own IP address. And all of them come from AWS own IP address or any other cloud provider. So with this, then we mitigate the risk, but frankly, it's not easy to make it go away. We mitigate the risk by running on different IP address that could be changing. And then if there's a need to, we do leverage on different cloud providers to run some of the scans on the infrastructure.
Sorry, also as a follow-on, are there any techniques that you can share of how to discover the origin servers that are behind this, that are hidden by the CDNs?
In terms of discovering origin, it depends on the organization. So it's obviously to discover if something you're hitting is origin or not, it depends on the different metadata you see could be from the response header or any other headers. That could be one way to discover if the host you're hitting is origin host or not origin host. And then depending on the organization, you may be able to discover the schema of them, setting origin host, or another way of doing that is, for example, if you are able to get ASNs of the organization, then you could technically send a host header on the origin host, on the IP address they are exposing externally to be able to discover if they could be origin hosts. But it really depends on the organization, and as a best practice, many organizations do block the origin hosts, but you do see, and we do see many times where origin hosts are exposed, and those are some of the techniques that we do to discover if the origin host at least on skill, right?
Okay, thanks.
Thank you.
Any more questions? If not, let's thank Samuel again for his sharing.
Thank you very much. Thank you.